Hi everyone! In this video, you will learn how to generate question-answer pairs from the chunk that we created in the previous step. In this step of the pipeline, you are going to generate questions that can be answered by a chunk of text. Note that a chunk can answer one or more questions, and a question can be answered by one or more chunks. Here's an example. I took this chunk of text that describes the bits and bytes Python package. And then I asked a large language model to give me questions that can be answered by this text chunk. It gave me more than 2 questions, but I just took these 2. And the most important thing is that in this step, we need to validate these questions. They need to be relevant to the chunk. For example, here I can start to read. Here, bits and bytes enables accessible large language models via k-bit quantization for PyTorch. And the first question asks, what is the primary purpose of bits and bytes? And this can be answered by the first sentence of this text. And after that, the text says, bits and bytes provides 3 main features to reduce the memory consumptions. And those are 8-bit optimizers, 8-bit quantization, and 4-bit quantization. And the second question asks, what are the 3 main features bits and bytes provide for reducing memory consumption? And the answer to this question is what I have just read right now. So you can see that the questions that the model generated, they are valid and we can keep them. And because this is a simple task, it is guaranteed that a large language model will give you very good answers. So that's it for the theory. Now let's code. Before I show you the notebooks that I have created for this video, you will find the source code on this GitHub repository. I will make sure to put the link in the video description. So please take the source code and play with it while watching my explanation. Now let me open VS Code. Here are the notebooks. I have 2 notebooks like before. We will keep doing the same thing. We will have one notebook for proprietary models and one notebook for open source models. And here, the proprietary model that I chose is Gemini, but if you want, we can easily switch to other providers. So the third notebook will allow us to generate question-answer pairs. In the previous step, we have saved the chunks inside the chunks folder. I have done this for the Roguestrix document, and here I have, I think 43 chunks. When you clone the repository, you will be able to access this JSON file because I have pushed it to the repo. Now we will take these chunks one by one and we will ask Gemini, and here I chose Qwen for the open source model, to give us the questions. Let's see how we do this. So first of all, we start with the system prompt. These are simple tasks that can be performed just by playing with the system prompt. I started by describing the task. So I told the model that you are an expert at generating relevant questions given some chunk of text. And after that, I tell the model that this is very important for creating question-answer pairs. Basically, I describe the task. You can describe it however you like. But what's important is telling the model the output format and giving it examples so that it understands the task. So the output format is going to be a list of JSON objects, because this is what we want. We want multiple questions per chunk, and each question should have this field. It should have just one field called question. So this is the output format. And after that, I immediately give the model examples. Here I took the same text that I showed you in the slides, that talks about the bits and bytes library. And after that, here is the output. I have another example, which is much longer than the first one. If you don't give the model examples, it might behave differently, but the examples will help you guide the model, and the model will always behave the same way because it will try to mimic the examples that you gave it. Let me run this cell At the end, I have a notes section where I tell the model to not generate questions that are similar to each other, because sometimes the model might give you two questions, but if you look at them closely, you will see that they are basically the same. And here I also say to stick to the JSON format, and the questions should be relevant to the text. After that, we will create a Pydantic object, because we saw in the previous video that Gemini can accept Pydantic objects as input to basically guarantee that the output will be a valid JSON. And here, because I have just one field, this is why I have created this class with one field called question. Now we can use Gemini to give us a list of questions. Here I created a function that will generate those questions. It will take the text chunk, the system prompt, and the model. By default, it is set to Gemini Flash. We will send the request and receive the questions. Inside the generate content method, we provide the content. The content will be the system prompt and the text chunk. In the configuration, we mentioned that we want a JSON. It is here that we use the Pydantic class. And here we tell the model that we want a list of this object. After that, when we call the parsed, when we get the content of the parsed attribute, it is guaranteed that it's going to be in this format. Now let me run this cell and let's go. I have created this function because we will be calling it for each chunk, and after that I will have a for loop that will call that method. But before using the for loop, we need to load those chunks. As you can see, we have 43 chunks. This is what I showed you in that JSON file. And now we can use that function. So we are going to loop over those chunks, and the chunk is an object. Let me open the JSON file again, just to show you what it contains. So each object has two fields, the ID and the text chunk. I told you in the previous video that this ID will be used in this step, and let me show you how we do that. So we get the text object. From that, we can extract the text chunk. We are going to give it to the generate questions method. And after that, we will get the list of questions. And here we need to link the questions to the chunk. That's why we needed that ID. And here, after getting the questions from Gemini, we are going to link them to that ID. Let me run this one time so that you can see what I am talking about. And here I have added this time.sleep, because if you are using the free tier, you will get rate limited quickly. So this will prevent you from getting rate limited. But if you are using a paid API key, make sure to remove this line so that this process will not be slow. Let's look at the question answer pairs list. Or first of all, let's look at the questions. As you can see, this is a list of this question class. And if we look at the question answer pairs, as you can see, all these questions are linked to the first chunk. And this is going to be used in one of the upcoming videos. So we are just preparing the data to be ready for the comparison later. And now this will loop over the chunks and store the questions and link the questions to that chunk. I have already done that, and I was able to generate 266 questions from all those 43 chunks. And after that, I have saved them inside another JSON file inside the question answer pairs folder. Let me show you this file. As you can see, so here we have the first questions that can be answered by the first chunk. We have, in the second chunk, we have how many? 1, 2, we have plenty. 1, 2, 3, 4, 5, 6, 7, 8. So in the second chunk, we have 8 questions. Now we have seen how to implement this with Gemini. Let's go to the other notebook in order to show you how to implement this with any open source model that you can run locally with either llama.cpp or transformers. So let's look at this notebook. I chose to use the Qwen tree model. This is a model that I can run locally, and you can find it on Hugging Face. Let's click on this link. because I want to show you again how to download these kind of models. Here is the repository, and here you can see the quantization levels. And if it is red, it means that you will not be able to run it. But if it is green or orange, that means that you will be able to run it. But because we are going to use llama.cpp, even if it shows you red, that does not mean that you cannot run it, because you can split the model. You can run some layers on the GPU and the other layers can be run on the CPU. And if I switch to, for example, here I have CPU with 40 GB of RAM, you can see that now all of them are green, which means that I can run them. I chose the Q4 version, Q4KM. So you can click on it to start downloading, or if you have more GPU VRAM, you can go up to Q8. Let me go back to the notebook. So this is what I have mentioned here. After you download the model, you need to run the server. So let me take this command and run the server in the terminal. Let me zoom in and paste the command. I am not using 999 in the number of GPU layers, but instead I am using 18 because I cannot fit this model entirely on the GPU, as you saw on Hugging Face. But 18 works fine. If you go lower, the model will start to become slower because you will start to upload more layers, a few layers to the GPU. But in my case, 16 or 18 works fine, but I need to keep some memory for the context. So I'll just upload 16 layers. You need to see this message. Server is listening on a port. I chose this port, but you can choose any other port you like. Good, now we can run the notebook. So after that, I took the same system prompt, so nothing changed here, but I am also creating the Pydantic object. But the only thing that will change is how we call the model. We are going to use that endpoint with that specific port that I have used in the llama-server command. And here, this is how we generate text. We are going to call this endpoint v1 chat completions, and we are going to give it two things: a list of messages and the maximum tokens that we want to generate. But what's important is the list of messages. First, we set the role to system and put the system prompt there. And in the user prompt, we will have the text chunk that we want to extract questions from. And after that, we send the post request to this endpoint, and we get, and from here we get the assistant message, which is basically the reply that contains the questions. And because here the output will be a string, we need to parse the output manually. This is why we are passing that message to the parse questions method. Let's look at it. So because that's a JSON, and hopefully it should be a valid JSON, because the output will not be very big, so the model should be able to output a valid JSON. If that's the case, the JSON.loads method will not throw any exception. And then we are going to create instances of the question class. So let me run this just to show you how this works. After that, we load again that JSON that contains the chunk. And here we loop over the chunks. And here I also have this getUserPrompt method. You can add some text before and after that text chunk just to simulate the user's turn. So inside the loop, we get the text chunk, the user prompt, we pass them to the generate questions method, and the rest is the same. Now, let me run this just once to show you the output. And if I open the terminal again, you can see that we were able to, we received the request. And here, as you can see, the generation speed is 15 tokens per second. Let me decrease the font. Yeah, this is better. The generation speed is 15 tokens per second. That's not bad. And let's go back to VS Code to see what we got. Let's look at the length. We got 5 questions from the first chunks. Let's look at them. And the output looks similar. We have the question and we link it to that specific chunk. And finally, we save the question-answer pairs inside the question-answer pairs directory. So as you can see, it is very simple to run local models, and I am 100% sure that they are going to perform very well in this task, because it is not a very complex task. And if you want, you can change the model. You can also try the Gemma models or GPT OSS if you want. So feel free to try any open source model. You know how to download GGUF files, so try them and see if you can get good results with other models. This is it for this video. In the next one, we are going to talk about embedding models.